Get involved in your local community at the school level, homeschool level, church, elementary, middle school, junior high, high school, and college level. If you are a production worker, skilled trades, technician, engineer, supervisor, management, sales, or marketing, you have enough knowledge to affect the deficit of STEM education in this country. This is my third in a series or effort to appeal to people to get involved anywhere they can. You cannot wait for someone else to do this. This requires action on our part. This is a grassroots, ground level swell. It has to go ahead of what the government's doing. You can't wait on them. When considering action versus inaction, anything in life, if you're not sure you should do something, action versus inaction, ask yourself these 4 questions. If I do this, what is the best possible result? What's the best thing that can happen if I do this? Second question is, what is the worst thing that could happen if I do this? The worst possible result if I do this. What is the best result possible if I don't take action, if I don't do this? And the last, you've already got it figured out. What is the worst result possible if I do not do this? If you apply these 4 questions to anything, any decision you're going to make, actually write them down, you will find that the answer is very clear in every single situation. Let's jump into VEX123. Let's take a look at the bottom of this puppy. You see there's a built-in gyro and accelerometer. An accelerometer is I guess you could say it's an integrated circuit chip that is sensitive to any kind of motion on 3 axes. That's why if a little puck runs into something solid and can't move forward, that inertia is detected and the system knows that it's run into something. There's a command that you can use that detects that. Other than that, you've got 2 optical sensors, a line detector and an eye sensor. The eye sensor is forward looking, and of course the line detector is on the bottom. It's looking straight down at the center for a line, to follow a line. Other than that, you got 2 wheels, and notice that there is a removable inspection plate or cover for the drive section, which means it can be repaired. We won't go into that. But what I want to point out is that at each end, perpendicular to the wheels, there's a little bump. As a matter of fact, on top there, built-in gyro, that arrow points to an area in the puck, but also you see a little bump right there, raised area, and then one down by the line detector. So when this little robotic puck is moving along on a surface, it's being driven by the traction or friction of those 2 wheels on the drivetrain, but it's also sliding on those bumps, which means that the accuracy of its motion is going to be drastically influenced by how smooth and even the surface is of your playing field. And remember that even though it has a accelerometer, it really doesn't know where it's at. So there's no algorithm in there or compass that allows it to have a reference point to keep going straight. So if you were to turn this loose on, we'll say, a 10-yard long surface, and you were following a straight line, not with the line detector, but you aimed it to go straight, you would find that it changes direction slightly as it goes because of variations of friction or traction with those 2 wheels. And when it rotates, the wheels are both powered, but they're in opposite directions. So in one instance, one's going clockwise, the other's going counterclockwise. You rotate left, and just the opposite to rotate right. So that is one of the drawbacks of this puck, but it's perfectly suited for an introduction level to robotics and programming. Without going into a lot of detail on how you connect up these devices wirelessly, this is just a kind of a taste of working with these products. So we kind of talked about programming that little green puck. It comes red, green, blue, and I don't know what else. I think just those three colors. You have 5 buttons on top there. Forward 1 increment. Then you've got rotate to the left, stop, rotate to the right, stop. And then you've got make a sound. The middle button is used to start the touch sequence that you put in directly to the little robot. But the next step up from that is programming it with the VEX coder that you can see there, the handheld. And when I say handheld, it's just about the size of a cell phone, maybe a little larger. And you have these 31 unique programming commands over to the left. Now there's more than 31 cards in the set, but there's 31 unique. Because remember, you have multiples of drive 1. You have 4 of those, and you have multiples of turn left and turn right, because you're going to need more than 1 each for any kind of a sequence. But notice the VEX coder only has 10 slots. The first slot is when start 1, 2, 3. So that's not considered one of the steps, but it does enable the start button up at the top. And then you have 1 through 10 slots that you can slide in these cards. And we'll go over these commands in groups, starting with the output. So there's outputs and inputs, or you could say inputs and outputs to all computers, called I/O, input, output. So let's look at the output behaviors first. You got drive 1, drive 2, drive 4. Those are increments, or they say robot lengths. And then you got, it says turn left and turn right. I like rotate left, rotate right, because you can't go left or right while the robot is moving. So it has to stop. Then it either rotates left or rotates right. Turn random, I don't know what you would use that for unless it's for entertainment. Turn around. That's nice because it gives you a 180. You don't have to do 2 rotates. So you can use 1 card to get a complete 180. And then you have another drive until object. That would be the forward sensing optical sensor that detects an object. So if you use that drive until object, it'll just keep going all the way across your playing field until it encounters something in front of it. Then it's going to stop and go to the next command. Drive until crash. That's where the accelerometer comes in. And if it drives and then hits a solid object or an immovable object, the accelerometer is going to have a drastic shift in inertia, and it will then stop and go to the next command. Drive until line. So this one, it just drives continuously until it detects a line. So if you turn the little fellow loose, drive until line, and it doesn't encounter any line, it's just going to keep going in one direction more or less until the battery runs dead. Okay, so those are the drive or motion motor wheels type outputs. Behaviors or actions. So these are the actions that you normally associate with a robot. Motion. Then you've got sound. So there's a little speaker inside of that puck that can play a honk, a doorbell, a crash, or something random. And then the LED light, which is in the center of that puck, it can glow purple, green, blue, or off. And there's no particular meaning to any of those colors. So the indicator light in the center of the robot will glow one of these colors, and I do believe that you have to use the glow off to turn it back off. So if you do a glow purple, it's going to glow purple until you do a glow off. Now, this is an output from a light, so it doesn't affect the motion or the sequence. This is just to enhance maybe the optical pleasure for the people using this product when they're learning. And then you have control input queries. In PLC programming, we would call these true if on, true if off. In text programming, if then else. But we're dealing with young people here, so if they have no introduction to code, then it's simply if object, which means if if the eye sensor detects an object in front of it, then you have to follow that up with something else. If, then, do something. And then if there's no object, it does something. If it detects red, because remember that optical sensor in front facing, it also has a capability of recognizing red, green, or blue. And then there's also light and dark, which we'll just say bright and not bright, because I don't know if it's a 256 grayscale. I don't know what the details are on the range between what's bright and what's dark. And then you can actually interact with a robot during the sequence with the rotate right, rotate left, move forward, and the sound button. Now, if you press these buttons, so let's say that in your VEX coder you have it go until it detects an object and then it stops. Okay? Then you can push the right button if you want to do something, left something different, and the move button, sound button, something completely different. So in other words, you can put into your sequence an interaction with those 4 buttons. And of course, a crash is if it runs into an object, not detected by the photo eye, but by the accelerometer. Then the last 2 of the control input queries, else and if you use any of the if, and then you follow it with a command, if you do a else, then if it doesn't detect red, then you can use the else to have it do something else. In other words, if it detects red, then do something else. If it doesn't detect red, then do something different. And then, of course, if you are going to use an if sequence, you have to use an end if. So really that's a lot to try to use in those 10 slots. But there is enough going on here so the learner kind of gets the idea of sequence with these commands, because these commands are very similar when we get to the next type of programming, which is with VEX code. Then you also have event buttons. The when start is always in that first space, what to do if you hit the start button. Go to start is very important, so you can run a loop. So in our sequence of commands there, from when start down 1, 2, 3, 4, 5, 6, when it gets to 7, it'll go back to start and continue just to run that program in a loop. Now somewhere in there you could put a stop. So you see the event buttons on the VEX coder, go to start and then stop. You can hit the stop button and it'll stop the program. Here's some more actions: compound, motion, sound. In other words, these are more for the entertainment of the learner than any real practical use. And I'm not going to read these to you, but act happy, act sad, and act crazy. You can read the descriptions for yourself. And then you also have time delays. And the time delay could allow you, let's say you say wait 4 seconds, and during that 4 seconds you can press one of those buttons, so you can do an else, or you can do it if you press the go forward button, then it does one thing. If you don't, the 4 seconds times out, then it keeps on going. So these are all the commands that you have using that VEX coder. You've only got 10 slots, so you can't do anything real complex, but you can have it repeat by doing the go to start. In the next video, we're going to talk about VEX code. So we're giving you an introduction to the 1, that is programming with the little membrane keypad on the actual puck, and then 2, which was with the VEX coder with the little command cards, and next we're going to do VEX code 1, 2, 3.